Okay, so we're still on 4.5, which means we're still doing use substitution. And the title of this is Solving Differential Equations. Do you think does this sound like something we've done before? Yeah, it kind of sounds, I mean, we've definitely solved differential equations. That means we have derivatives. And this is where we're starting out with the derivative, and we're going to be integrating. The difference is we're going to be finding C, okay? And this little information right here is how we're going to do it, okay? But before we get to that, we're going to kind of just go one thing at a time. But I just want you, this is to find C. That'll be the very last thing we do, all right? So when you're solving differential equations, the first thing that we did when we did this last semester was anytime you saw a y prime, you replaced it with dy over dx. Now in example 1, this is already done for you, okay? But if this had said y prime, we would need to replace it with dy over dx. You can see on example 2, we're going to have to do that as our first step. All right? Our second step is to separate the variables, meaning only y is on the left, only x is on the right. So on this first example, and we're just looking at this piece right here, are the variables separated?
No. Okay.
Not quite, almost. We got to put that dx over on the other side. And that's a step you're going to have to do quite a bit. That's going to happen a lot. And when I say we've done this before, but everything in front of the dx was much, much simpler. It wasn't like this, where you can see maybe we're going to have to do use substitution. All right, once you've separated the variables, meaning only y is on the left, in particular only dy on the left, and only x is on the right, this is where we're going to integrate. Okay, so we're going to integrate both sides. And remember, if you're going to integrate, there has to be a dy or a dx. So that's another reason you know one has to be on one side, one has to be on the other side. Okay, what is the integral of dy? 1 what? Y. Right? Basically, the antiderivative of the derivative of y is y. You can think of it that way. This is always going to happen over here. You don't really need to do any algebra or calculus. It's always going to be like that. Okay, now on this side, this is a problem like how you saw it in the homework last night or what we did in class yesterday. In order to do this, we are going to have to do use substitution. Now, there's one thing, though, that I think will make this problem easier, and that's kind of rearranging all of this. So, what do you think would be good for us to do with this 24? Move it to the very front. Okay. The other thing I'm going to do is, I just did this kind of when we went over the homework, is moving this x over. That's not a necessary step, but I do think it makes it easier to see what's about to happen, especially if you know you're going to need to do use substitution. That x is probably going to be connected to dx. It's going to make it easier to see. Okay, now I'm going to go ahead and just warn you now. I'm writing really big. I hope you're not writing as big as I am, because I can already tell I'm going to have to erase some of this to write over it. So if you're writing as big as I am, just start writing smaller, I guess. Okay, so u equals, what should u equal? 3x squared minus 1. So this is getting easier. Maybe you would even say this is easy now, picking out what u should equal. All right, then du should be 6x dx. Okay, so that wasn't too bad either on this one. So remember that we're just going to go through and we're going to substitute, and I'm going to change this if I need to. Do I need to change this? I need to divide by 6 because I don't see a 6. All right, and so u cubed, and then in place of x dx, I'm going to write 1/6 du. All right, from here, still have the 24. Now I'm going to move that 1/6 out in front, which is going to be what? 4. Okay, so you could go ahead and do that, 4. And then I have u cubed du. All right, so this is going to be 4 times, again, just kind of the bookends are the integration symbol and the du. So that's going to be 1/4 u to the 4 plus c, which the 4 and the 1/4 cancel. That's nice. And then the u, just look over right over here, that's going to be 3x squared minus 1 to the 4th plus c. Okay, this is not my final answer, but I am going to go ahead and box that. The reason it's not my final answer is because this is, we call this the general solution. This was all of the solution curves, where we didn't know what C is equal to. In order to find the particular solution, which is what they're wanting us to do, and I know that because they give me this definition. Otherwise, I'd have to stop. I wouldn't even be able to go any further. So I'm going to kind of create a little space right here. When x equals 0 and y equals 0, that should be enough information for us to be able to find C. Then we rewrite our answer and we're done. So this is one last step at the end, but it's not, it's an easy step as long as you have this correct. And so we have 3 times 0 squared minus 1, that whole thing to the 4th, plus C. And remember, this whole thing is equal to y, so I'm going to write it on this side just to make it easier to solve the equation, equals 0. So numerically, what does all this stuff in the front turn out to be? 1 or negative 1? 1. It's going to an even power, so I know it has to be positive. It can't be negative. So 1 plus C equals 0. That means C equals negative 1. And a lot of you on the last test we did, you stopped here. Okay? You got all the pieces. You've got the general solution. You've got C. But to really have your final answer, you have to actually write it out. Meaning, you got to write out this 3 squared minus 1, all to the 4th power, then minus 1. This right here is what we call the particular solution. But it is my final answer. So I'm going to put some stars next to it. So it's kind of like I've tagged on an extra step at the beginning and a couple of extra steps at the end. But the middle part is what we did yesterday. Now you may come across one of these where you don't have to do use substitution, and it could be like one we've already done. So most of the time, this week especially, we're going to do a lot of use substitution, so we need to practice it. All right, so let's look at the next problem. Let's see if I can... that. I'm trying. There we go. Okay. So, y prime sine squared x equals cosine x. What's the first step? Change this y prime to dy over dx. And then I have sine squared x equals cosine x. We don't need to do too much at one turn. That's usually where people get confused. Okay. Are my variables separated? No. What's the step we need to do?
Side by side squared.
Yeah, I definitely need to divide by sine squared x. And that's going to be dy over dx over here. And then what? Multiply by dx, and this is definitely an okay thing to do. I think that nobody's going to get confused by doing that. If you feel like you might, though, then just write it as an extra step. Okay, so definitely my variables are separated. I'm ready to integrate both sides. Now, the left side is going to be y equals, and the right side, we got to integrate. If we were doing, like, does anybody think they know what u should equal on this one? If we're doing u substitution. Sine x. Good. Now, you had one kind of like this in the homework, and I'm going to challenge you to think outside the box, because if you can be clever with your trig, you actually get out of doing u substitution. So cosine over sine squared, that will simplify into something else And I totally won't have to do substitution at all. I'll get out of it completely.
Isn't it cotangent x times 1 or times
Yeah. Yeah, cosine over sine, I'm hearing from a lot of you, is cotangent x.
Right.
And then I have an extra sign in the denominator,
1 over sine is cosecant.
cosecant. And this, the reason I say this is easier is because that already is a derivative. You do not need to use u substitution if you're clever with your trig. What is this the derivative of?
Or the derivative?
This is the derivative of what?
No, it should be.
Well, let me just say this. If this is the derivative, it's of one of the 6 trig functions. It's not of something really complicated. Yeah, cosecant, and we have to have the negative because the derivative, like if I were to just write cosecant x right here, the derivative of cosecant should be negative. The fact that there's no negative here, I'm going to put that in. Now, of course, you could have done it if you're like, I don't like doing that. That's confusing. I never would have thought to do that. Then you could have done a u substitution. Let u equal sine. You would have done a few more steps, and then you would have come up with the same answer. Probably your answer would look like negative 1 over sine x instead of writing it as cosecant, which is totally fine. But this right here is the general solution. Now, the paper here doesn't give you an x and a y, so you would be done on this problem, except that I'm going to go ahead and give you an x and a y, because I think we need to practice this. Okay, so I'm going to say let x equals pi over 6 and let y equals 0. So it's not a whole lot more, but it's just one more step. So I got to plug it in. Got to plug pi over 6 in for x, and I got to plug 0 in for y. In other words, let the whole thing equal y. And your goal here is to find c. So you're going to have to evaluate. Now, you could just say, well, c has to be positive cosecant pi over 6. That's correct. And even on the AP test, if you wrote that, you would not be penalized for not evaluating. But I want to challenge you because there's a lot of times when evaluating makes the problem easier, so we need to practice this. So how do we find cosecant of pi over 6? What do you think, Ashley?
I would just do negative 1 over sine of pi over 6. And
Okay.
then you just figure out what your sine of pi over 6 is, and then put negative 1 over that.
All right, so we need to find out what sine of pi over 6 is, and then just do the reciprocal and put a negative on it. So what is sine of pi over 6?
1.
Okay, so maybe for the rest of us, our trig is a little rusty. Anybody with me on this?
Yep.
Okay, so let's go over ways that you could come up with this. First of all, how many degrees is pi over 6? 30. So could you draw a 30, 60, 90 triangle and use SOHCAHTOA to find sine of pi over 6? Yes. All right, that's the first way you learned how to do it back in geometry, and that's how you could always do it. All right, remember I also taught you that trick, the hand trig trick, so I'm going to go over that one more time. If you're watching the video, sorry, I can't. You're just going to have to listen. So remember that this is the first quadrant, your left hand. Your pinky is 0, your ring finger is pi over 6, and then pi over 4, pi over 3, and pi over 2. It's just like your your pinky and your thumb are like the x and y axis. And so pi over 6, since that's your ring finger, you're going to hold that in. Now, you're either going to count the fingers above or count the fingers below. Do you remember which one was for sine? Below. As I said, sine looks a lot like the word sin. And would you correspond the word sin to above or below? Below. Okay. You know. Wait, what? However you remember it, it's totally fine. Whatever. Okay, so you're going to do, it's always square root of fingers over 2. So sine of pi over 6 would be square root of 1, because there's one finger below, over 2. Well, what's square root of 1? 1, right? What would cosine of pi over 6 be? Square root of 3 over 2. All right? So that's there to help you. For some of you, that's like the last way you're ever going to want to do it. But for some people, it really helps for them to like use their hand. It's like they're that type of learner. So I don't know. I just want to get you all on the same level. But we need to be really, really good at this and pretty quick. So if sine of pi over 6 is 1/2, then that whole thing would be -2 because we're going to flip it around. So all that to say that C has to be 2, and then your final answer would be negative cosecant x plus 2. You've got to put this in there. Positive, because it's -2 plus C. All right, so what you're going to do now is you're going to work example 3 on your own. I would encourage you to look at both of these examples because there's aspects of both of them that you're going to need. And then we'll go over it before you leave. Okay, let's finish going over this. As I was going around, I saw some common struggles among different students. It seems that you guys are pretty good. This was the new stuff today, moving everything over. Okay, y'all seem pretty good with that. Y'all are great at picking out what U should equal, and you're really good at finding DU as well. The thing that a lot of you are struggling with is, okay, well, what do I do next? Okay, so, move it up. There we go. Oh. Okay, so I'm going to go ahead and write the integration symbol. And our goal here is to replace everything in here with something from this circle right here. Okay, so if U is equal to x squared plus 1, then I've got to substitute that in. Right there. Now what I have left is this x dx. Okay, so I see an x dx here, and the 2's in the way, and so we got to move that over. Y'all were pretty good at knowing that that was probably going to happen. And so either we can put 1/2 du on top. That's totally fine. I'm going to go ahead and just write it as another term and just put a 1 here on the top. This is the key step that I think a lot of you are struggling with. From here, what am I going to do with that 1/2? Move it to the very front, so I don't have to deal with it at all. And then 1 over something, okay, that's going to be u to a negative power. Square root means 1/2. Now, when you're trying to integrate this, remember that you're just going to kind of block out everything except that what's right in between the integration symbol and the du. And so if you're not really sure what this is, leave a space, write your u, add 1 to your power. What do you get? 1/2, and then write the reciprocal in front. Like the 1 over, basically it's 1 over 1/2, which would be the same as 2. All right, 1/2 of 2, that canceled, that was nice. And then just go back to your u. All right, you could definitely rewrite the answer with a square root symbol. That would be totally fine. And do we have enough information to find C? No, I would have to give you an X or a Y, but I'm going to spare you on this one.
Yay.